Hello everyone, welcome once again to another lesson in this Machine Learning Fundamentals Python series, whereby today we're going to be taking a look at what is known as scikit-learn. So what is scikit-learn, or sometimes referred to as sklearn? Well, it is the most popular library for machine learning in Python. It includes everything that you need to build, train and evaluate our models. So it has things from model classification, regression, clustering, and more. It's built on top of NumPy, SciPy, and Pandas, and it is easy to use. So this is what a typical workflow looks like in terms of we load the data, pre-process and clean, split into the training and test sets. We train the model using an algorithm of our choice, evaluate the model, and we improve if needed. Alright, so just like what we've looked at in previous lessons, this is the practical application of what we're actually going to be doing. So sklearn is a framework or a toolkit that allows us to do this in a quick and efficient manner. Okay, so the first thing that we need to do is, of course, install scikit-learn. And we do that in the following way. So we do what is known as a pip install, and we call scikit-learn. Okay, we also have another what's this? Using conda. Okay, so next up, installing scikit-learn. So we can install using the pip install, or we can use a conda method. We, of course, are going to be using the pip install. So you'd simply do pip install scikit-learn, and we then verify that it's installed correctly by doing import sklearn to import it, and we can print on screen the current version. Alright, once we see that the version is up and running, sklearn is installed and we can begin to use it. Okay, so next up is loading example data. So scikit-learn includes built-in datasets, for example, like this iris dataset here. It's a classic one for testing classification models, and it simply contains flower features and species labels. Okay, you can view the feature names, target names, and sample data. So the features are measurements of the flowers, for example, and the target is the species labels, as an example. Alright, and so these are the commands of how we do each one of those. So next, if you remember from previous lessons, we want to split the data into training and a test set. So the training set, we by convention split it as 80% split, whereby the test set we have as much smaller and we use 20%. We can also do a random split using this random method. Alright, and so this is how we do that below. And so we're going to take a look at this in our practice time. Next, we choose a model type. So in this instance, we are using k to the nearest neighbors. Alright, which is classification based on the closest training examples, uses 3 closest points to decide, as we're using 3 neighbors here, classifies based on proximity in the feature search, and it's an easy to understand and implement algorithm. Alright, so we'll look at k to the nearest neighbors example when we do our practical. Next, we want to train the model, and we do that using the fit method. So this teaches the model to learn the pattern between the features and their correct labels. Alright. Once trained, we can use a predict method in order to make guesses about the test data. So these are labels. So these are the labels the model thinks are correct. The next thing that we want to do is, of course, measure the accuracy to see how many the model actually got right. So to check how good our model is, we compare the predicted labels with the real ones using accuracy score. The closer to 1, the better it is. Alright. Okay, next up we have a confusion matrix, which shows how many predictions were correct or incorrect for each class. So this helps you to see not just the accuracy, but where your model struggles. Next up, scikit-learn makes it easy to try different models. So we can just swap out the model class and everything else stays the same. For example, we can try a decision tree as opposed to k to the nearest neighbors by simply importing this line of code just like so. Simple as that. Alright, so just to recap, we've seen how to load data, how to train a model, how to make predictions, and as well as how to check its accuracy. And so this is the foundation of machine learning in scikit.